Thank you very much, Anisha. So welcome again, everybody. So I'll talk a bit more about the work that we're doing here at QCRI. So I'll start by talking about data for development, and then my colleague Ferda will talk more about our crisis computing efforts, and then Stephan will talk more about our Arabic language technologies. I'll basically tell you about sort of 3 example projects that we are doing. So one that was briefly mentioned this morning already, which is about mapping poverty in the Philippines, which is a collaboration with UNICEF and Thinking Machines. Then I'll talk a bit about a project on tracking digital gender gaps. So this is in collaboration with Data2X, which is part of the UN Foundation, and the University of Oxford. And then last but not least, I'll talk about our work on monitoring the Venezuelan Exodus, which is joint work with UNHCR and UNICEF, and also our colleagues from IMAP. I think we'll also talk more about this in the afternoon. The first 2 projects, so this is a gentleman who's actually doing the actual work. So Masumali is here in the room sort of or so. So if you have any sort of technical questions, or just give him a shout out sort of or so. So he's the one who deserves all the credit for this. And he's been working on, even this while he was still at Princeton. So he did this during a summer internship here. And then he joined now full time. So we're very glad to have him here. And then this gentleman here, Joao, who is probably also in the room, who's at the back somewhere. I can't quite see him. He's hiding there, sort of. So is leading our efforts on collecting migration data related to the Venezuelan Exodus, sort of. So if you have very in-depth questions, then Joao would be the person to talk to. So what we're using actually for all of these 3 projects is data from Facebook. That's aggregate anonymous data that's publicly available with Facebook's advertising manager. Just to sort of explain the type of data, here's a sort of screenshot that I took yesterday. So here I'm about to launch an advertising campaign targeting people. Oh yeah, I have not moved into. I tell people first. Sorry, camera crew. Sorry. It's just. Okay, so hopefully the laser pointer will, sort of, indicate the spots. So this is in the industrial area. I sort of indicated, I'd like to show an ad on Facebook to people in that part of Doha. The people I'm targeting on Facebook are men. So you see the gender listed down here. Who used to live in either India or Nepal, right? So there's now some sort of migration background information that's available. And then further down, I'm combining this with, it must be using an Android device rather than an iOS device or sort of high-end device to access Facebook. And now, crucially, before I launch my advertising campaign, Facebook provides an estimate of how many people match these targeting criteria, right? So according to Facebook, there are 42,000 people. So according to documentation, these are monthly active users who are in this part of Doha, who used to live in either India or Nepal, and to use an Android device to access Facebook. So just to sort of illustrate what you can do. So now, what do we do with this type of data? So first, we put together a visualization for Doha in particular. So I don't know if Michael is here in the room, who also contributed to this. Who's our visualization expert to this, and this is publicly accessible online. Just ping me later if you can't take a picture sort of now. So we're according to now this visualization of Facebook data. So look, just very briefly. So the people from Nepal are found mostly in this part of town. They're almost exclusively men. And they're almost exclusively Android device users, and they're fairly young. If you contrast this with people from Western countries, they're in a very different part of town. They are older, and they're actually more likely to use an iOS device than an Android device, right? So indicating that they have higher disposable income. So this is already gives you the clue that we use the device type information to map poverty. So now apart from whether it's iOS or Android, there's also information available whether it's let's say iPhone X or Galaxy S9 Plus, so you can sort of target particular devices, and then again you're provided with this estimate of how many people match your targeting criteria. So by looking at which parts of the Philippines, in which parts of the Philippines people are more likely to use an iPhone X to access Facebook, or are more likely to use a feature phone to access Facebook, we can build models around this. So here's the actual model that was sort of built using Lasso, if that means something to you. Sort of this, like a regression model with built-in sort of feature selection. So it uses a combination of the fraction of Facebook users that use 3G and that's actually sort of lowers the wealth as opposed to the fraction of Facebook users who use 4G, which is like a positive coefficient, or users who use Wi-Fi, iOS, or other sort of high-end devices. And then also Facebook penetration itself is positively predictive of higher wealth. Just to show what it looks like sort of graphically, sort of or so. On the y-axis, you have data from the Demographic and Health Survey for this, what they call sort of clusters. These are sort of like basically locations with a bit of radius around. And then on the x-axis, you have sort of predictions based on the model. It's not great, sort of or so. It's like, it explains just under sort of 60% of the variance. But we're still quite happy about this. I mean, first, the ground truth is also not perfect. It's already lagging by 2 years, and there's some noise introduced. And so we're sort of quite happy about these current results. Here's what it looks like sort of also across the different provinces in the Philippines. For the digital gender gaps, it's a similar type of data source. So if you look at just how in Switzerland, where I last gave this talk at the ITU, if you look at how many men are on Facebook in Switzerland, it says 2.2 million. How many women are on Facebook? It's 2 million, right? So it's more or less gender balanced. If you look at a country such as India, there are 230 million men on Facebook, as opposed to 66 million women, right? Now the question is this just Facebook, right? Maybe, for cultural reasons, women don't join Facebook, or is this actually internet at large? So what we do is we built a model where, actually first we created a website. So this is, again, I should acknowledge this is a collaboration with people at the University of Oxford. This is a publicly accessible website called digitalgendergaps.org, where first we show you the data from the International Telecommunication Union. So countries where there's some color out there are countries that report data on gender-specific internet access gaps to the International Telecommunication Union. So a light green color means that for every man online, there's also one woman online. Whereas if you go down to the red, for every man online on the internet in general, not Facebook specifically, you'd only have 0.43 women online, right? So you see that sort of Western Europe and North America is doing fairly well, but countries such as Pakistan or sort of also are lagging behind. But you also see there's a lot of unknown, where there's missing data, right? So now what we do is we use data from Facebook to build a model to make predictions for these countries with missing data, right? So now based on our model and based on what we observed for India, we would predict that for every man with internet access in India, there are 0.72 women with internet access. And yeah, there are different models you can try, and you can combine online and offline data. We also make predictions for mobile phone data. Very sort of quickly, you can combine using just online data is on the left. This is just Facebook data alone. You can make predictions for a fair amount of countries, and you get a decent R squared of 0.69. You can use just offline data. Then both your performance drops, so the R square is lower, but also you can make predictions for fewer countries. By combining them, you can make even better predictions, but now you're relying on availability of both data sources together, which reduces the number of countries you can make predictions for. Apart from just internet access or not, we also look at ICT-specific skills, such as whether, the same sort of thing, whether men or women know how to use copy and paste tools. So again, on the left, there's very limited ground truth available, and on the right, we make predictions for this particular skill. There's other data sources out there, not just Facebook. So the same sort of method also works for LinkedIn, for Snapchat, Instagram is part of Facebook, or for Contact here, for Weibo, or for anything internationally. Where here, for example, you can look at how many women in Germany on LinkedIn are in a leading position according to LinkedIn data. So you can sort of use this to monitor occupational gender gaps. And then 2 minutes, okay, perfect. I'll just briefly talk about, and then I'll hand over to my colleagues, just briefly about the Venezuelan crisis that was already mentioned this morning, right? So there's a large outpouring of migrants and refugees, and I deliberately sort of use these terms interchangeably, even though there's, this talk just about the terminology. They're crossing mostly into Colombia and other sort of neighboring countries. There's a lot of I mean, there's lack of reliable data sources, data on the topic, partly due to irregular migrants, or people don't participate in service due to a fear of persecution, and this ultimately leads to a suboptimal humanitarian response. So just to show you the magnitude of the crisis over time and how non-traditional data sources come in is, so here on the very left, you have a snapshot of data that we collected from Facebook, where we would look at how many people who used to live in Venezuela now live in other countries, according to Facebook's estimates. And you have sort of on the very, very left, June 2016, very, very small estimates. Now, since June 2018, Joao has been collecting this data sort of regularly, and you can sort of see the numbers go up and up. What the sort of upper and lower bar means, sort of the lower bar just means the sort of the values as they are on Facebook, and the upper bars are sort of correcting for Facebook penetration in different countries. For reference, you have an estimate by OCHA for all of Latin America. So this would be sort of like the gray colors all combined, sort of. So anyway, sort of like at least in terms of order of magnitude, what you get from Facebook is actually reasonably close. But even if you don't look at absolute numbers, just the trend has been going up, and has been going up dramatically since 2 years ago or 2.5 years ago. But it's still been going up over roughly the last year. Now, how do you validate this, right? It's sort of like tricky, because now you don't have ground truth, which is kind of the whole point of doing this, right? So if you already knew the answer, why bother, sort of. So, well, we try as much as we, as good as we could, sort of. So here's now something where also IMAP helped us in the access to this RMAV data. So this is sort of like official, registry for migrants. And what you see sort of down there in 0.71 is now not the value correlation, but the rank correlation. So you'll see that the two maps in terms of sort of ground truth and quotes on the left and Facebook on the right, they don't perfectly match in terms of sort of colors, sort of also in terms of values, but in terms of sort of rank, where the areas with the largest number of Venezuelans, they seem to be reasonably close aligned. So keeping in mind the limitation of the ground truth, we actually think this is a reasonably good data source, and we'll hear more about this in the afternoon. Again, another validation is at the country level. So before it was subnational just for Colombia. This is now at the country level for several countries, a similar sort of picture, where in terms of just looking at the countries where Facebook predicts the largest number versus where OCHA has the largest estimates, there's pretty good agreement, even though the absolute numbers, they don't necessarily align. But now we can also make predictions for places where there is no data available. For example, for Brazil subnationally, or Peru subnationally, or Ecuador subnationally. Again, here we don't have any ground truth to validate against, so it's sort of hard to say if this is good or bad, but we are reasonably confident that this is actually meaningful, at least in terms of order of magnitude and spatial distribution. You can go even further down, sub-city. So this is just the city of Roraima in Brazil, where you can now even see the part of town where Venezuelans are probably more likely to be found. And then just last thing, so not just the numbers, it's also you can get qualitative insights. So here we now referring to the first thing I mentioned, if we look at the operating system that people use to make a prediction about their income, right? So as you have in blue is the predicted income for Venezuelans living in Venezuela, and now the different colors are Venezuelans in different countries, right? So we predict the highest income for Venezuelans living in Spain, but even in Brazil, within Brazil, you have these two different sort of yellow bars, right? The Roraima with a very low predicted income, where Sao Paulo would be very high predicted income, right? And at least anecdotally, for Spain, this seems to be plausible, right? That sort of the people can make it all the way to Europe, probably have a higher disposable income. You can do the same for education level as well, where we would look at like self-declared education level for Venezuelans in different parts of a country or for different countries. Sometimes, there are good things and bad things, right? Sort of also, right? The global reach, real time, it's anonymous and aggregate. So there's less privacy concerns to a certain degree. You can disaggregate by many. I'll take. You have to be more okay. Big limitation, black box, right? We don't know exactly what's being done. Things change over time as well, and only measures people who are online. If you want to learn more about this, we can offer experience with this data analysis skills. We need more connections to real-world problems, and partnership is fairly unbureaucratic for us. We don't have to sign anything. We've been working with people who heard before anything. Okay, so now I'll hand over to my colleague Ferda.
Thanks, Ingmar. So as you all know, natural or human-induced disasters such as earthquakes, floods, conflicts, and wars, disturb communities, destroy infrastructure, cause fatalities, and leave thousands of people without the basic needs of life, such as food, shelter, medicine, and so on and so forth. And these crises also bring up uncertainties and challenges to humanitarian organizations to deal with unanticipated situations. And one key factor that allows humanitarian organizations to launch relief efforts is information. And, but when information is most needed, it may be scarce. And unfortunately, in traditional methods, like sending someone on the ground to collect such critical information, it takes days or weeks to obtain useful information. To close this information gap, we developed a system called Artificial Intelligence for Digital Response, AIDR, which capitalizes on social media data and employs state-of-the-art machine learning techniques to classify and extract useful information to provide humanitarian organizations in their rapid response efforts. To deal with high volume and high velocity social media data, AIDR combines human and machine intelligence in an expert machine crowd setting. That is, once a humanitarian organization defines the type of information that they need, our system starts collecting data from social media, and then the data gets annotated through our humanitarian volunteers using our crowdsourcing platform called Micromappers. And then we use the annotated data by these digital volunteers to train machine learning classifiers to perform the task automatically. And eventually the output of this hybrid system is presented to the end users in various formats. And I'm happy to tell you that the system won the grand prize in Open Source Software World Challenge in 2015. And one of the output of our system is a map like this. We created this map during Hurricane Harvey that struck US in 2017. Our system collected and classified tweet messages into various humanitarian categories like infrastructure damage, injured or dead people, urgent needs, and so on and so forth. And projected this information onto a map when there's geolocation information was available. And maps like this with real-time updates are a highly sought-out feature because these basically provide critical situation awareness to humanitarian organizations. We also deployed our system in many other natural disasters in the past. This is just a short list of many deployments we had. For example, in Nepal earthquake, the information we provided to UN OCHA helped them save 8 lives, and which is a nice success story. Although this system was developed to help humanitarian organizations in rapid response efforts, the system can also be used in many other contexts and scenarios. And for example, back in 2014, AIDR was integrated into UNICEF's U-Report system in Zambia to automatically categorize the incoming health-related questions and route it through the corresponding health professionals so that they could provide the most accurate response and support to vulnerable population in a timely manner. Another similar example is the deployment of AIDR's technology during Suffolk County New York Marathon every year. And back in 2015, an interesting event happened. And our system detected a tweet talking about a bomb with this picture of a pressure cooker setup attached. We reported this to the event organizers. Event organizers escalated the issue to FBI. FBI investigated the case. Eventually, it was not a real threat, luckily, but it was a case well worth of investigating, and the event organizers were thankful to us for our system to detect such an important message. Inspired by this example, and also in general motivated by the fact that a picture is worth 1,000 words, we extended our system to process also images, social media images in real time. We developed a pipeline that analyzes the incoming images and classifies them into different overall damage assessment levels, in this case severe, mild, and no damage. And we tested the system in the Atlantic hurricane season in 2017. The initial results are promising, but having an overall assessment of damage into 3 categories is good, but not enough, and we need to deal with this problem in a much larger scale. That is, we need to deal with data in the extreme wild, And specifically what we want to do is we want to be able to identify critical infrastructure types and places. At the same time, we want to be able to identify the cause of damage, like among various disaster types that played role in this setting. And such an exploration requires a large-scale disaster image data set, which we are currently creating. And a very early stage demo that we built using this initial data collection already yields promising results, like shown in these examples. But this is not the end of the story for us. We want to maximize our data utilization by analyzing images and textual content together in a multimodal setting. There is, here for instance, we have got an image that shows severely damaged house, which is useful information, but where exactly is this house? Where can we put on a map? Luckily, in this case, when we look at the corresponding tweet text, the text says this picture was taken somewhere in Rockport, Texas. Now, all of a sudden, the information becomes much more interesting and useful. Similarly, let's say we have a text message saying that there was a 6.1 magnitude earthquake in southern Mexico. This is, again, somewhat useful, but what was the actual damage incurred by this disaster? And again, in this case, the corresponding image reveals the severity of damage incurred by this disaster. So inspired by these examples, we went ahead and collected a large-scale multimodal data set, annotated it for various humanitarian tasks, and started developing a robust system that can exploit this multimodal content to extract highly accurate information. And apart from our online and free-to-use system, AIDR, we are also developing crisis data processing services for helping technical and non-technical users, experts in the crisis informatics domain. These services include RESTful APIs for technical users and web-based file processing interfaces for non-technical users. And for now, we have support for text processing services, including disaster type prediction, informativeness classification, and humanitarian categorization. But we plan to also release our support for image processing in the near future. And in addition to analyzing social media images, we are also interested in analyzing UAVs and satellite imagery in humanitarian context. And in the past, back in 2014, we partnered with Kuzukis Wildlife Reserve in Namibia to help them with their wildlife protection efforts using UAV imagery. Again, in 2014, we deployed our systems to detect damaged coconut trees using UAV images collected after Typhoon Haiyan in the Philippines. 1 year later, we partnered with the World Bank to help them with their damage assessment task after Cyclone Pam in Vanuatu. And very recently, we started collaborating with UNICEF and UNESCO on a project for detecting damage in cultural heritage sites, especially in crisis and war conflicts. So with that, I would like to conclude with this slide, which summarizes the research and development activities we have in crisis computing team. My colleague Imran and I will be around throughout the day, and we'll be happy to discuss further if you have use cases. And
Hi, I'm Stephan. I'm the research director for the Arabic language technologies team here at QCRI. So I just wanted to give a few pointers what we work on. We don't work on the social computing aspect. So here it is more about what we could, or what could be useful. It has already been mentioned in earlier presentation that Arabic is often missing. So typically processing is done, text processing is done on English. So in ALT, we are working and have been working on a number of projects, which I just want to point out, and then we will be around, and some of the colleagues are here, and we will be available then for discussions, some of which have already been set up. So right now we are active in 4 areas: the Farasa project, CUTS, automatic transcription, Tarjama, machine translation, Tanbif, fighting fake news. And then we had also a number of projects in the past which have come to a conclusion, are no longer pursued, but may also be of some interest. So one system we are working on, which is essentially basic Arabic natural language processing, is the Farasa project. And we have, for example, Karim and Ahmed Abdelali. So our cameraman is actually a Farasa man. And he wears some other hats as well. So this is essentially, doing all the basic processing of Arabic language. So, for example, named entity recognition, but then also segmentation, the morphological analysis, all the way to part of speech tagging or parsing and so on, diacritization, which is restoring the short vowels which are not written in Arabic but are necessary for some tasks like text-to-speech. So for all of our systems, we always try to have some online demos where you can go to and you can play around with yourself. So for example, here, the Varasa, there is an online interface where you can copy and paste some text into it, and you just can click the different techniques. Right? So this is a kind of fundament of Arabic language processing, and I should point out that in all of these different tasks, we are state of the art or setting the state of the art, and typically our tool processes text much faster than competitive systems. CUTS is our QCRI advanced transcription system, so this is speech recognition, turning voice into text. So we focus mostly on Arabic. We have also developed an English system. So it's actually based on some open source toolkit, the Kaldi toolkit, which is widely used in the community, both research and companies. Initial focus was on broadcast news, which is mostly modern standard Arabic. We are now moving more and more into dialect processing, which of course is important. There we also actually organize, so our colleague Ahmed Ali is the lead in organizing competitions, international competitions, to improve the state of the art in Arabic language or speech processing. Related to this is then also dialect identification, so that we can identify who someone comes from speaking, and we do dialect identification both on the acoustic, so when we have speech, but also processing on text. So for example, Hamdi, who is also sitting here in the audience, right? So can we identify the origin of a speaker or of a writer from text material? So this system has been deployed for many years. So we do automatic video subtitling for Al Jazeera. Our system is right now used in the Shura Council, and we are in discussions with BBC. They are interested in licensing our system, which of course is showing that it's the quality. We also do we have an online system, where you can upload some video clip, it detects the audio, it generates maybe subtitles, and you can download the file. Tashama is our translation system, so we do text translation from Arabic into English and English into Arabic. Again, we have an online system. So traditionally, we worked on the so-called phrasal statistical machine translation. Now we are using the deep learning, and it's called neural MT. Again, initial focus was on broadcast news and on lectures. We can combine these two systems to do speech translation. So we have an online demo for this, where you can speak Arabic, it translates into English, or you can speak Arabic and it translates into Arabic into English, or English into Arabic. The Tanbi project, and this has also been mentioned in some of the other talks, so and it became very popular in recent years, so all the news, how reliable are they, right? So this is a project which is led in our team by Breslav, who is back there in the audience and is available for further discussions. So there we concentrate on reliability of sources. For example, can we automatically put a label onto this, on factuality of reporting, on high partisanship, on propaganda. So what are the techniques? Can we identify the techniques of propaganda used in different? And again, you can access this. Actually, we are developing a kind of news aggregators where these things then are added value to it, right? So you can read your news, but then you can also dig a little bit deeper to see about the reliability and factuality and so on. Older projects which we have done, which I just want to mention. So we have been working on community question answering. So essentially, all these forums where you can ask questions, the same questions have been asked, 100 times. And so the system could then rank answers given in the past, how reliable or how relevant they are to your new question. And this was actually deployed at Qatar Living Web Portal. So this is just a screenshot from the system. We have been working on optical character recognition, especially for historic Arabic documents. Years ago, we had developed an eBook reader focusing on Arabic. This was in response to the so-called eBook initiative in the country. So it has been field tested in schools. It was very strong on supporting rich multimedia, interactive content, and so on. And it has been released in the Windows Store. We have also been working with the local community of blind, visually impaired people to develop a keyboard for iOS. So instead of the two-handed brailing, it's actually one-handed brailing because people, they walk around, they listen to the voiceover, and they want to type the answer. So we developed this, and it has also been released into the App Store. Thanks.